All right, welcome to the very last on 4.4 water pollution. Today in this video, we're going to be looking at the process of eutrophication. So eutrophication is the enrichment of a body of water with nitrates and phosphates, generally nutrients. Okay, and so we are going to be looking at nutrient enrichment and what happens to a body of water, how that leads to hypoxic, anoxic conditions with low oxygen. And you will also need to be able to evaluate pollution management strategies in respect to nutrient pollution / eutrophication. Okay. And then after this video, I want you to go back and use that pollution management strategy to also do plastic. Okay, so let's take a look at eutrophication. So eutrophication is the enrichment of a body of water with nitrates and phosphates. Okay, so it's this rush a whole bunch of extra nutrients like nitrates and phosphates that get into a body of water. That is eutrophication. But what it leads to is very low, a positive feedback loop that leads to low amounts of oxygen. Okay, so eutrophication can occur when lakes and estuaries and coastal waters receive inputs of nutrients, nitrates and phosphates, and that's going to result in a bloom of usually phytoplankton algae that will then result in there being very low oxygen conditions, and it's often hard to get back. So here's the body of water that's really green. I'm sure you've seen some lakes or maybe even rivers like this. Usually if it's this green and just like that, it can indicate that eutrophication's occurred and it's very hard to get it back again. So it's probably very low oxygen conditions. It's probably reached a tipping point. So what happens when you get a whole bunch of algae growing because of the nitrates and phosphates that get into the water? And where they're coming from, the nitrates and phosphates, is usually from farms. So in industrial agriculture, spraying a whole bunch of nitrates and phosphates on the farm is going to lead to, when it rains, that those nitrates and phosphates getting into bodies of water. Well, because nitrates and phosphates are usually a limiting factor for algae, when all of a sudden you get all these nutrients, then the algae just goes crazy. Like, oh, we got all these nitrates and phosphates. And so the algae starts growing because, aquatic algae, plants, and other things really like that extra nitrate boost and phosphate boost. Well, when you get that excessive green algae mat, that's going to block sunlight for the aquatic plants underneath. So they can no longer photosynthesize. If plants can't photosynthesize, the byproduct of photosynthesis is oxygen, right? If they can't photosynthesize, we're going to have less oxygen in the water to begin with. Well, if you have less oxygen in the water, plants are going to die, and because they can't photosynthesize. And the other thing is the algae at the bottom of the mat, that tends to die off too. So you end up getting a whole bunch of dead organic matter in the water, dead plants, dead algae, and you need decomposers to decompose that for decomposition, and that's going to suck oxygen out of the water. Now, this isn't necessarily a sewage pipe causing this, right? This is like you've got this nutrient enrichment that could be from a sewage pipe, but a lot of times, generally, we're looking at the runoff being from these nitrates and phosphates from farms, okay? And that's going to cause an algae bloom. It blocks the light from the plants die, the algae at the bottom of the mat dies, it decomposes, the decomposers suck the oxygen out of the water. Well, lack of oxygen in the water, hypoxic, anoxic, low oxygen levels, animals will then die. The fish can't live anymore, right? All those animals that need the clean water with lots of oxygen. And if they die, then they have to be decomposed. So that creates a positive feedback loop. That's an important aspect you need to talk about when you're talking about eutrophication. Okay, so those animals die, they decompose, and that takes more oxygen from the water. So more organisms die, and they decompose, and it takes more oxygen. So everything's being amplified. And you end up getting dead zones. Okay, it's really hard to recover when there's no oxygen, everything's dead. So you need to be able to outline the process of eutrophication, but you have to be able to identify those positive feedback loops. Okay, so the eutrophication is the enrichment with nutrients And then the process that ends up happening is all of the oxygen ends up getting sucked out of the water because of decomposers. And it's a positive feedback loop. Here's some dead zones that happen in both oceans and freshwater from nutrient enrichment. Okay, so when the rivers come out, you can see here's an example. There's very low oxygen and things not living there very well, right? Happens in the summer a lot too because there's plenty of light for the algae to bloom. So places where there was a lot of coastal fish and other things, they're not going to be able to survive, and that's going to kill fishing industries, right? It's going to kill tourism. It's going to kill, imagine what happens to coral reefs. Okay, so these dead zones are a really big deal. So how does it happen? Well, nutrient enrichment can happen through deforestation, inorganic fertilizers, phosphates that often come up in detergents, and there's phosphates in a lot of dish soaps and things that gets it sudsy, and so that ends up in the sewage. And if it doesn't get treated, then that's in the water. And then, of course, untreated sewage wastewater, because there's a lot of nutrients there too. Okay, so that's how we end up getting the nutrient enrichment in the first place. And especially if the inorganic fertilizers, those phosphates and nitrates that get put on, if they get spread on during the rainy season, they put it on and then it rains, it goes straight off into the rivers. So that can be a pretty big deal. Here's just an example of showing you after you cut down trees, what happens to the water in the area. So if you leave the trees up, the nitrate levels are low in the water. If you cut all the trees down, then a lot of the nitrates end up flushing into the water because you've taken the nitrates from the soil can then just be flushed into the water, and so it ends up being taken away, and then you get all this nasty nutrient stuff in the water. Here's what a very eutrophicated river looks like, and you can see what's causing it. All of these farms probably. Here's some other examples of what causes it. Discharge of untreated sewage, nitrogen compounds by cars and factories, natural runoff, inorganic fertilizer, runoff from feedlots and other things, right? Ammonia. So here's all these different ways that it can get into a lake or a stream or river, okay? That nutrient overload, now the oxygen tends to leave because you need all those decomposers to break it down. Okay, so you need to be able to evaluate the pollution management strategies in respect to water pollution. You're going to have to do it for another thing too. I want you to do it for plastic, but you also need to be able to look at it in reference to eutrophication, nutrient enrichment. Okay, so remember the figure 3, you've got alter the human activity, you've got to control the release of the pollutant, and then finally clean up and restore. So there's these 3 different levels. Okay, so for eutrophication, the production. So how do we reduce the production? So we got to alter that human activity in actually producing it. So you could do that through education campaigns, right? You can do it through economic incentives or disincentives, which can say, hey, don't use detergents with phosphates in them. Use the organic ones, the ones that don't get as sudsy. Use better technology in your washing machines to pull some of those things out. Reduce the amount of fertilizers that you're actually putting on the fields, or switch to organic fertilizers. Organic fertilizers, like if you use manure and compost, that's more of a slow release. That holds the water there, and it's a slow release of nutrients because the decomposers are letting the nutrients out, right? So it's not like you just put it on and it gets washed away. The organic fertilizers keep this slow release of nitrates and phosphates happening within the soil. You can not apply fertilizer during a rainy season. That would be helpful. Okay, and now the release of the pollutant. So if you're going to reduce the release of the pollutant, so you're kind of making the pollutant, but you want to make sure it doesn't get into the waterways at this point. So one thing you can do is plant a buffer zone. So if you have a bunch of plants and other things that can absorb the nutrients on the way, so between the farm and the stream. So if there is rain that washes the pollutants off, the plants will catch it and absorb it before it ever gets to the stream. So you've released the pollutant, but you're reducing its impact, okay? You can also treat your sewage and wastewater and remove those nitrates and phosphates before they actually get into the waterways too. And then finally, okay, eutrophications happen. You've gotten those nutrients into the water. So what do? So you can either remove the pollutant or you can restore the ecosystem. right? Well, it's really hard. The hypoxic mud, the mud that doesn't have very, like at the bottom with all the decomposers and stuff, you can actually try to pull that out and drain it out of like pull it out of lakes and things. It's really hard to do. You can actually pump oxygen to as well into it. You can, if all the fish and plants have died, you could like restock the pond, but if there's no oxygen, they're just going to die again. So that is another thing that you can actually kind of aerate. If you pull out all the algae and kind of aerate and remove some of that mud, then you can reintroduce those plant and fish species as well. So this is like the hardest one to do, obviously. All right. So you need to be able to evaluate these strategies. What are the pros? What are the cons of it? Right. So you're evaluating the strategies, not just listing them. And then you also need to do this for plastic pollution.